All right, let's continue on with some properties of logarithms. So before we do that, let's talk about some exponent rules. So we learned about the exponent rules where if you have the same base getting multiplied to each other, you can just add the powers. Same base getting divided, you subtract the powers. And then if you have the base to a power to another power, you multiply the powers. So again, remembering that logarithms are just undue exponents, you can kind of see how these relate with the logarithmic rules. So multiplying, if you've got log base a of mn, you can separate that out as two logarithms by using the addition property of logarithms. When you're dividing two things, you can separate that out using the subtraction property. And then this is one of the really crucial ones where if you have log base a of something to a power, you can actually move that power right in front of the logarithm. So for example, if we had something like log base a of 5 to the x power, this property allows me to move that x in front, which is great because it gets that x outside of the logarithm. So just a tip, these properties do need to get memorized just like you had to memorize exponent rules. So as you work through applying these properties, write them first every time you use them, and the more you write them, the more you'll remember them. The other thing that I can recommend is creating some note cards with these on them where you'd put, for example, this on one side of the note card and this on the other side that you can kind of take with you and constantly quiz yourself. If you're one of those that has a smartphone and like to use your smartphone more, there's a great app that's called Quizlet that it's a free app that you can create note cards in digital format to keep on your phone and then just kind of quiz yourself whenever you've got some extra time. So let's look at some of using these examples. So use the properties of logarithms to find the exact value of the following expressions without a calculator. Okay, so let's write those properties again that we just learned. So log base a of m minus log base a of n is the same thing. We can combine those by dividing. Log base a of m plus log base a of n, we can combine those by multiplying. And then if I have something to a power, I can move that power in front of the logarithm. Okay, so looking at letter A, you can see this matches up with this first product or property. So I can combine these two logarithms since they both have the exact same base. So this can be combined as log base 3 of 6 divided by 2. And now I can rewrite this as log base 3 of 3, and I can simplify this further. 3 to what power is 3? And that's 1. Looking at letter B, I can combine these using this addition property. So log base 8 of 16 times 4 equals log base 8 of 64. So 8 to what power is 64? And that's 2. So it's kind of neat where these properties allow us to take something that's pretty ugly and make it into something that's very simple. All right, looking at letter C. Okay, so the first thing that I'm going to do is I'm going to combine these using this property because they both have the same base, base 4. So this becomes 4 to the log base 4 of 7 times 8, which is 4 to the log base 4 of 56. And now I can use that other property, which was a to the log base a of a number just equals that number. So since this base of the exponent is the same as the base of the logarithm, we can simplify this and say this is just 56. So let's do some more. Now let's do the opposite way. So with the last one, we took things where they were expanded and we simplified them into one expression. And now let's take those properties and write each expression as the sum or difference of logarithms. The one thing that you want to make sure that you're doing as you're doing this is make sure that you're expressing all powers as factors. So again, writing those properties up here, just so that we have them for reference. And again, I really recommend that you are writing these down, because the more you write them down, the more you're going to have them memorized. Okay, looking at letter A. Now, sometimes you're going to see these little things, sometimes you won't. So when you see this in your book, this is just the author saying, okay, so remember we're dealing with logarithms. Whatever you're taking the logarithm has to be a positive number. So we need to make sure that the domain is x is larger than 3. All right, looking at this. So I can see that this matches up with this first property where I have two things getting divided by each other. So I can undo that by changing it to the difference of logarithms. So following this property, this becomes log of 1 minus log of x minus 3. Make sure you put that entire thing in parentheses. Now, one thing that students want to do is they want to distribute this logarithm through and say, oh, well, this is just log of x minus log of 3. Notice there's no property that we've learned that allows us to just distribute the logarithm through. You're taking the logarithm of this exact argument. So you cannot distribute a logarithm through. So don't get in the habit of doing that, because that will get you the wrong answer. Got to only follow these properties. And I can actually take this a step further, where the log of 1, so remember that's log base 10 of 1, so 10 to what power is 1, and that's 0. So this just simplifies into the negative log of x minus 3. Looking at letter B, I'm going to first expand this out using this multiplication property. So this becomes log base 3 of x to the 4th power plus log base 3 of the 5th root of 1 plus x squared. Now, the one thing that they want us to do is to express all powers as factors. So that means to take any of these, to use this property basically, where if you have a power, move it to when it's in front of the logarithm as a factor. So we'll move this 4 down. Now remember that taking the 5th root is the same thing as putting something to the 1/5 power. So now that I've rewritten it like that, I can move that 1/5 in front. And remember, again, we can't distribute this log through, so it just stays just like that. There's nothing else I can do to simplify this. Looking at letter C. So I'm going to use that division property first. So this is the log of the square root of x squared plus 4 minus the log of x squared minus 4. Okay, I can go another step further. So this is the same thing as x squared plus 4 to the 1/2 power. And for this one, I can actually simplify this out as x plus 2 times x minus 2. So this gives me 1/2 times the log of x squared plus 4. And then for this logarithm here, I can actually use this product property to expand this out. But I have to remember that I'm subtracting all of this. And then I can have my distribute that negative sign through, and I get 1/2 log of x squared plus 4 minus the logarithm of x plus 2 minus the logarithm of x minus 2. Let's continue going. So now let's go back to writing things as a single logarithm. So we're going to now do the opposite direction. So notice with all of those properties, so for example, log base a of m minus log base a of n there weren't any numbers in front of the logarithms in order to be able to use this property. So for example, looking at letter A, I can't just use that quotient property yet because I have these numbers as factors in front of the logarithms. So again, let me write up these properties really fast. And again, I really suggest you do the same. Okay, so the first thing I'm going to do is I'm going to use this property to get these factors written as exponents. All right, so that gives me log base 3 of x to the 5th power minus log base 3 of y to the 6th power. Now I have it in this form where I don't have any numbers in front of the logarithms. I have the same base for each logarithm, so I can combine these using the quotient property. So this becomes log base 3 of x to the 5th over y to the 6th. Looking at letter B. So letter B, luckily I don't have any factors in front of the logarithms, so I can just go straight to combining these. So this becomes, I can use the product property, square root of 2 times the cube root of 2. Now I want to simplify this more. So let's continue going. So this is going to bring in properties of exponents. So that's the same thing as 2 to the 1/2 power. This is the same thing as 2 to the 1/3 power. So when I combine these, this gives me 2 to the 1/2 plus 1/3 which is log base 4 of 2 to the, so let's see, 1/2 plus 1/3. We need to get a common denominator, which is 6. So you multiply this side by 3 over 3 and this by 2 over 2 to get that common denominator. So that gives me 3 over 6 plus 2 over 6, which is 5 over 6. And I can actually take this even further. So if I was trying to figure out, to analyze this, this is 4 to what power is equivalent to 2 to the 5/6. So let's just set this equal to x for right now. So 4 to what power is the same thing as 2 to the 5 over 6? Well, I can write these both as a power of 2. So now that I have them both written as a power of 2, I'm left with 2x equals 5 over 6. Divide both sides by 2, which is the same thing as multiplying by 1/2. And I get 5 over 12. So this entire thing ends up equaling 5 over 12. So looking at letter A, we knew we couldn't go any further because this base is not the same. I can't write this as base 3 at all. But here I knew that I could continue going and get a simpler version of this because 4 can be written in terms of base 2. And so that's why I decided to take it this last step further. Okay, looking at letter C. So first thing I'm going to do is write all powers or factors as powers. So this gives us log of x plus 2 plus log of x minus 1 to the 2nd power minus log of x squared minus 2x plus 1. And then what I'm going to do is kind of follow PEMDAS, properties of order of operations. So I'm going to do the addition and subtraction in the order that it was that I see it. So I'm going to deal with this addition part first. So that's going to give me the log of x plus 2 times x minus 1 squared, all minus the log of x squared minus 2x plus 1. Okay, so now I can actually do the division property. So I'm going to go over here. So that gives me the log of x plus 2 times x minus 1 squared, all over x squared minus 2x plus 1. So now I want to see if I can take this a little bit further. So I know the numerator of this is factored, but the denominator I can factor. So that gives me x plus 2 times x minus 1 squared on the numerator. The denominator is x minus 1 times x minus 1, which is x minus 1 squared. So now I can see those cancel out. And I'm just left with the log of x plus 2.